Hey, this is Kaspar, and I'm starting a new series called Building Platforms with Kaspar, in which the title suggests is I'm going to build internal developer platforms that I'm seeing out there in the field used by dozens and hundreds of developers in large-scale setups. Now, in this video, you're going to see it all. We're going to look at the architectural diagram. We're going to learn more about repository design. We will then actually look at the GCP setup, at the backend, the pipelines, the orchestration. We're going to explore the observability setup, the portal layer. We're going to look at my local setup. And then we're actually going to look at how golden paths work. We're going to get to a point where you can actually press a button and then the service gets created and the infrastructure gets created and the environments are spun off and all of the pipelines are configured. You can literally git clone, locally start developing, fully integrated with your AI pair programming tools. And this works end to end. We will learn on how to just rapidly add new resources to your application, how to spin up ephemeral environments, and all of that in this video. I'm going to record more of these videos with different setups, with different clouds, multi-cloud on-prem, and I'm going to interview friends and other fellow platform engineers that have built amazing internal developer platforms and want to show them to the world. So if you have one, reach out. Would love to have you on this show. And with that, let's get started and build some platforms. Now, let's actually understand a little bit how this is architected and what different components we're using. And I'm going to start from the infrastructure and we're going to work our way up. And then I'm going to deep dive on repository design. That might feel a little strange, but I think it's super important. And then I'm going to really show you all of the different parts of the platform and how that fits together. And once we have that, I'll show you the design of golden paths and we'll just actually use it and see how requests and things and self-service actions fly through the platform. Yeah, so let's start here with the infrastructure. So this is using GCP and I've selected Kubernetes as the compute. We could use VMs or serverless and I will use all of those combinations in some of the next videos. But for this now, we're going to use Kubernetes. And then we're going to use Cloud SQL and Cloud DNS and PubSub and a couple other infrastructure resources, the usual suspects, so to speak. All of this will be represented as infrastructure as code. I'm a big believer that everything should be represented as code for disaster recoverability, etc. And we are going to use Terraform for that. It could be anything else, OpenTofu, Pulumi, whatever. Now, if we look at the backend structure of that platform, I'm very backend heavy. If I develop platforms, I think about repositories first, think about backend second, and then think about everything else. If we look at the backend, I'm going to use GitHub Actions for CI, and then I'm going to use the updated version of the Humanitec Orchestrator. So this is the new version that's compute agnostic as the logic handling component in the backend. And then I'm going to use the artifact registry of Google. If we look at the version control, I'm using GitHub like everybody else. And then for the IDE, I'm going to use Cursor, and I've also woven in Claude Code because I think it's so important that we demonstrate continuously how to fit AI and all of those things into platform designs to help users use those coding agents productively. So we're also going to cover that. On the UI level layer, the portal, the pane of glass, the view into our platform is going to be port. And I'm going to show the dashboards, the logics, the self-service data points here from that perspective as well. For monitoring and logging, we're going to use DataDog. And then on the security plane layer, we're going to use Cloud Key Management Service for the secrets management. So this is the rough design of our platform. Before I show you the components, I want to talk about repository design. And that might feel a little strange to you. Why the heck would you do that? But I think that every good engineering setup, first of all, starts with culture, right? The technology is the secondary step. But if we are now into that secondary step, then the thing that's very, very important is repository design because it sort of manifests your culture. I almost think about repositories like the DNA of an organization. Like, show me your repositories and I can tell you who you are. I can probably get a pretty good idea about how you're organized, how well your teams work together. And so I really like to take a step back, even if you're 5 years in the journey already, and say, how do we think about the structure of repositories in general or from now on? Now, let me show you repository structures that I don't think are super helpful or set the right incentives. One of the structures that I'm seeing a lot is the idea of pushing everything into one repository, right? We're looking at an application in an environment, and you'll see all the application source code, obviously the pipelines, the configurations. You'll see in our Kubernetes example, the Helm charts, the Terraform files for every single resource, and it's all in one repository. So first of all, that shows me you're not really thinking a lot about specialization, because I continue to be a big fan in large setups to say there are specialists for infrastructure and there are specialists for application development. There's nothing wrong with that. But second, it shows me that you're not really thinking about standardization, right? Because it now means that you have these individual Terraform files in every single repository. And if you think about how much complexity that creates, right? You have the application in different environments and you have different dependencies. That means 300 to 600 files if we just look at one application with 10 services. And that means 30,000 versions every month, right? And those are things you need to maintain and you need to secure and you need to update and all of that thing. Then that can become very, very difficult at scale. Again, for smaller setups, whatever, it doesn't matter. But for large setups, for the enterprise world, that really, really matters. Now, the first approach that some people do is that they say, okay, let's sort of separate these worlds. You have the application team and you have the infrastructure team. The application team has their repositories, and then we have these infrastructure repositories, and we have one repository for all of the different resources in all of the different states, and we sort of somehow try to organize this. And if the application developers need something, they can write a ticket, And that is also not a great design, because you still have a lot of the complexity and you are introducing silos, and there's nothing bad about silos, but silos without the right interfaces in between, right? You want to have developers be able to go really fast. And for me, the thing that has continuously shown the best results is to introducing abstractions and really introducing that concept of a backend for your platform, where you're codifying rules and you're giving developers a way of actually requesting stuff and expressing what they need. And this works as follows. The developer stays on the application level, deals with the configs there, really makes sure that they are responsible for that code. And then they define in abstract terms, my workload needs a S3 bucket or Postgres, and it needs DNS and whatnot. And then if that's getting sent to the CI pipeline and hits the orchestrator, which is sort of the backend of your platform, the orchestrator will look at rules, and the rules are defined by the platform team and or by the infrastructure groups, and they'll contain things like workloads are always observed by DataDog. And if we're deploying to staging, then we want to use a specific way of defining Postgres, but this should always be the same for staging. And if we create a new DNS, then that should be done in Cloudflare. So all of those rules are codified here. And then if the request from the developers comes in, the backend can pull those rules and actually dynamically create the representation of that environment. It also means that we now have a backend that knows how an environment is put together, right? You have a backend and an API that you can call, and you can say, hey, that workload, what are the resources? What's the state? And if you then think about it from a structural perspective of the repository, you have the developers that really deal with the application source code, and you have the platform source code, so to speak. Those are your Terraform modules and the providers and the configurations for the backend, and that allows you to really reuse stuff. So you might only have 4 or 5 different ways of configuring Postgres databases and staging, and that can be reused and it can be globally updated and all of those fancy cool things. Okay, so now we have the rough repository design under our belly, right? And now we really want to look at how does that look in reality. We will look at the infrastructure repositories, and we will see how this is actually wired up on the backend, on the orchestration level, to really reach that developer autonomy, be able to go really fast, specialize on the application source code, but not be actually hindered by that abstraction, and have a backend and infrastructure setup that drives sanitization, and that's really, really streamlined and efficient. And so let's actually do that. So here we have our demo infrastructure repository, which is a pretty standard Terraform setup that now contains all the Terraform modules that tell us how, is Kubernetes configured, how's the cluster configuration, how are the Postgres databases, all of those different things. And then it also contains the rules, like when am I supposed, or when is the platform supposed to use which type of configuration? If the developer says, I need a namespace for a development environment, how can we codify that the backend of the platform knows what of these files to use, how to spin stuff up, how to wire things up? And that is also here in the code configs, but that's a little harder to read. So I'm just going to show you the user interface here, and that's sort of the console of the orchestrator, right? That's the console of the backend of your platform. So everything you're seeing here is just a UI representation. It's stored as code. Remember, it's so important that everything is represented as code. What we're seeing here is that we've defined and we've introduced the conventions of what environment types are available on our platform. So in this case, we have development staging, production, and ephemeral environments. And then we have decided what resource types are available. Those are the molecular bits that the application developer can then actually choose from. In this case, we have buckets and DNS and Ingress and namespace and Lambda as a compute and Postgres and queues, whatever. You can do whatever you think is a resource or whatever your application developers need, you can put in here. And then we have the modules, right? The modules are now saying, well, if somebody needs a namespace, and then certain rules are met. That could be we are deploying into a development environment, or what's the role-based access control of that user. Then I want you to use the following Terraform, and by the way, this is the mapping, and this is the provider that we're going to use, etc., etc. So this is really where we are bringing these things together and where we are codifying stuff. We're saying if somebody needs a resource of a certain type for a specific environment, and that's the request that the backend is getting, then we want to use this infrastructure as code, and this is how we're going to wire this, and this is how we're going to inject secrets, so the backend can take care for us, do that. And now you'll immediately see that this allows us to reuse stuff. So every time somebody requests a like a namespace for a development environment, we can do that in the same cluster, and we can use the same configuration for the namespace, and we can centrally update this. And we now also have that backend that gives every single one of my applications and environments and resources an endpoint that I can query, and I have a single source of truth. So it has a lot of these advantages and really leads to this streamlined and standardized flow. Yeah, so this is sort of the back-end structure of my platform. Now, let's also look at the equivalent repository and how that would look like for an application developer. So here you see that I have a pretty normal application. It's a simple front-end application. It has my source code. It has, in this case, Helm charts, which is something that probably the developer should be responsible for. And it has a manifest. And a manifest is the thing where developers describe what resources their application in general needs. We'll see that my workload needs a bucket of type bucket and a service account and namespaces. And, we could add something here. We could say, give me a queue. Then, I just need to... It is already proposing this here for me, so that's fantastic. And literally, if I type those two things and I send that through the CI pipeline, what will happen is that the orchestrator will pick this up and it will go, this developer has the following role-based access control. Perfect. They're allowed to do that. They need a queue. All right. Where are we deploying to? We're deploying to development. Now let's use this Terraform, whatever, to do that. Let's spin everything up, inject secrets, etc. Yeah. So that's the power of a well-crafted backend. Then let's also explore the other parts of the design, and let's look at how we're doing that here on the repository basis. We obviously have our GitHub action files. If we want to deploy, we have a specific workflow. If we want to create ephemeral environments, where we would be calling the backend and say, hey, give me an environment of type ephemeral, and it would create the equivalent infrastructure. We have one file that actually registers all of the changes back to the portal, to the service catalog, to the UI, to make sure everything is stored there. And then we have the usual things like Docker files, etc. Yeah, so if we look back here at our diagram, we have an idea of the infrastructure set up now. We have an idea of the backend. We have an idea of the pipelines, the registries. And now I want to look at our portal layer. So in this example, we're going to use port as the portal. And this is my home screen. I'm just going to show you around a little bit. We have these little tiles that we can configure that just allow us to pull data from the data model or have markdown stuff. Like here, look at the entities, and you can see that I've wired up a lot of stuff, and I'll show you how that works in a second. We have these self-service actions. We have short links. Those are really the short links to my architecture here, right? And so we have a short link to the orchestrator, short link to GitHub, to the GCP console, to DataDog monitoring, to my infrastructure repository, etc. And then we can have some performance metrics, whatever helps us. Now, let me show you a little bit. So essentially, there are two big things in Port. You have the catalog functionality, import stuff, look at stuff, observe stuff, and then you have the self-service actions. Those are things where you start with something. If we look at the catalog, we can look at services, workloads, environments. We can build our own entities. We can look at our cloud resources. And this is literally pulled in from Google. And then we can look at our services, and we can see all sorts of things and entities and runs and audit logs and whatnot. That's an aggregate view of all of the different components of my internal developer platform. So it's pretty handy to look at, pretty cool. I can build all sorts of specialized views. How do I wire this up? Well, I just showed you in the repository that you have this port YAML that picks up this information and sends it up. There are also connectors through the API. You can install stuff in your Kubernetes cluster to pull in the GCP stuff. There's really no limit. You can build your own data entity model. It's pretty straightforward. If we look at the self-service actions, that's the design of, or can be the starting point of golden paths, so to speak. That's also pretty straightforward. It's pretty much like normal BPMN design. You can start a workflow by calling a GitHub Actions in the backend or doing direct API calls, and you can configure those buttons here, and it's pretty neat. Now, let me just from here show a couple other things that are configured for this platform. So this is our DataDog monitoring, right? That really shows us all of the compute and the performance and the logging, etc. And then we have the GCP setup here for that project, and we have compute engine performance and billing and whatnot. And we have the orchestrator. I already showed you this, the GitHub org, infrastructure repositories, etc. Yeah, so this is really our pane of glass into all of this. And for me, it's very important that developers can go here. They can go anywhere else, right? So maybe they want to just stay in their IDE. Maybe they want to use coding agents. So if I'm now going to show you golden paths, I'm always going to give you sort of a couple options. And it doesn't matter because everything has this really strong backend here. Everything is API based. Everything is code based. So I can start from the portal. I can start from the IDE. I can do a direct API call. That should all work pretty well. You now have a pretty good overview of how all of those previous things fit together and how the architectural components interact with each other. And now we want to look at golden paths. So let's say as an organization, you want to give your developers the opportunity to spin up new services, microservices that have follow the observability standards that fit right into the platform pattern, that, you immediately have CI/CD, you immediately have infrastructure. All of that should be taken care of, right? We really want to select one template and then everything is there and I can start coding, right? How would we configure this? Well, first of all, you sort of need to create that service template repository. And we see we have a normal source code and we have all of those things. We have the design manifest again, all of this here, and it is marked as a public template. So that's always the starting point, right? You need to codify this on the repository layer. We keep coming back to that. Now, the next thing that we do is that we set an action in port if you want to be able to give your developers to push that from or as a self-service action. So you see, I've done this, create service from sample repository. Usually you have 20 different examples, give Node.js, Python or whatever you're using, and I just have this one sample here. And we are going to call it IDP building with Caspar. Okay, cool. And then we're going to hit execute and boom, this will now actually run and it will create and it will actually fork the repository. So just look at this action here to help you understand what's happening under the hood. This, if we look at the JSON structure, will actually now go into Git and it will call a GitHub workflow. And that workflow will go in and it will clone the sample repository that I just showed you. And it will start executing the workflow and it will forward the variable of the service name, right? And that's just an example. I can be more prescriptive. I can say like, this should go to Amazon, this should go to Google, or I need to have certain stuff, whatever variables you want to give your developers the ability to forward. And you could obviously also say, I want to have this on Kubernetes. I want to have this on Lambda. I want to have like a sample microservice that runs on or like sample service that runs on a VM. All of that is obviously possible. Exactly. So this is running now and it's going and it's pushing off this workflow, and this workflow is choosing this template, and then we are building this application in the background. All right, so in the background, the repository is being generated from the template. And if we go into the pipeline here, we can see that we have the initial commit, and then we are going to next actually get the deployment. And so what this is doing is that it is literally obviously building the image, pushing this to the registry, and then it is pushing this to the orchestration. And the orchestrator is then picking this up and is creating the infrastructure for us here in the background. So just follow along here. We started here and we used and scaffolded the repository. Actions is running now, push to the registry, push the orchestrator. The orchestrator is figuring out who's doing this, who's the developer, what rights do they have. There's a development environment, perfect. The resources in the manifest that are requested. So if we go into the code of the scaffolded thing here and then we look at the manifest again, we can see that it's requested a bucket and we need a namespace and it's going to Kubernetes, etc. So this is exactly what the orchestrator is going to give us. And so then a couple of seconds, actions should be ready. Okay, so now we actually have our initial commit that looks fantastic. And that means we have that service up and running. That service is literally now, we can have a look, pumped up back to pod. So if I go to pod, to the catalog, I should see it. Yeah, perfect. We have my IDP built with Caspar service. On the orchestrator console, I should see this as well. Yeah, perfect here, built IDP built with Caspar. We see a graph of all the resources that were created. If you think about the manifest, where the developer just said, what do we need? You can see that the orchestrator created the service account, the namespace in the bucket, deployment ID, and we have a log on. Okay, now if we go on that resource graph, we go to the deployment ID here, and we just look, search for that in our GCP console. We will see that we indeed have a Kubernetes job and we have a pod. And so that's actually configured and working well. So that's fantastic. Everything running here for us. Okay, so what do we have? We have the repository, we have all of the infrastructure, we have the pipelines, we have everything nicely registered in our service catalog, we have it observed with DataDog. That is looking very neat. And so the developer can literally go in and just say git clone my repository. And here we go. We have built with Caspar and we are ready to rumble and work and code and commit and deploy all the way to my development environment and spin up new stuff. It is really end-to-end ready. And you see that didn't take more than 2-3 minutes and we are done with that. Okay, so this is sort of the golden path. Just to revisit this, we are here, pod, scaffolding, this runs, we git clone and boom, we're ready to go and everything is wired all the way from the IDE down to the resource plane. Cool. Now, let's say we've been developing this for a while and we want to have a different resource. Again, we could go into into pod here. We have different self-service actions like adding a database. But let's say, as the developer, I want to stay in the IDE, which sort of makes sense, right? Like I want to not have to go into a different interface all the time. That's no problem. IDP building with Kaspar. So we can go into the manifest and say, now I want to have a queue of type queue. And I actually also want to have the queue name as the variable. And now that I'm ready, I'm just going to commit this. And now as I've done this, you can see that the manifest is being updated, and then this information will be pushed to the orchestrator, and the orchestrator will receive the information, hey, we need a new queue, and then it will figure out what queue to use for that context, and it will create the queue. All right, and now we can check whether we can already see that in the orchestrator interface. And yes, here we go. We have a queue actually that has a connection to the workload. That looks well. Fantastic. And now I also want to show you how you can run or steer the whole thing from an AI Copilot. And for that, I'm going to use Claude Code here. So let's just say I'm going to start with what resources does the workload IDP building with Kaspar have? Right, and so that means Claude Code is now going to reach out to the orchestrator, and it is giving us that information. So based on the information I received, it has a service account, bucket, namespace, queue. That makes sense. That's the thing that we just added. And we have workloads. Resources are exposed to the workload through environment variables. That looks good. All right. We can also ask other stuff like how often did I deploy this so far? Whatever we want to do with that information, just to show you that it can call the backend and get all of that information. But let's do something more useful, and that is create an ephemeral environment. Can you create an ephemeral environment for this workload so I can test something? It's a little bit of a misleading example because usually I would want to have that automatically created if I git push and I want to test. Just to show you that it's absolutely possible. And yes, I have successfully created an ephemeral environment called ephemeral test. And now let's just verify that that's actually the case by looking at this again. We should now see two environments, and that is absolutely true. We see default and we see ephemeral test, and I can go ahead and start testing with it. So this is really actually very, very impressive how precise those pair programming tools are able to use that architecture that I just showed you. And that's because the conceptual model is very simple. Everything is API backed. Everything is very structured. And because there's role-based access control on all of this, you can make sure that these coding agents don't go off and do some funny vibe coding things. Yeah, so that sort of concludes the amount of golden paths that I wanted to show you. In this video, what have we covered? We've covered the architecture, we've covered the repository design, we've covered everything from resource plane to the backend, pipelines, orchestration. We covered the pod layer with pod, the local setup with Cursor and Claude Code. Everything was observed with DataDog, Claude with the, we had secrets management in the background. So all of these things really, really work well together. And everything that I showed you feels like a lot, but I built that in less than 5 hours, I would say. Now, that isn't production grade, right? And it's very greenfield, and so that's a little naive. But you're able to get a pretty decent demo of that in, the 4 or 5 hours. Now, I have a little bit more experience, but let's say 10, 15 hours, absolutely possible. And this is less daunting than you think. Just take the stuff that you have right now. Do you have ServiceNow? You can use that as a portal. Do you have GitLab? You can use that as CI and version control. You're on Amazon, no problem. So you can wire all of these things up. You can apply the design principles that I just showed you. And this is a pretty bulletproof pattern. Now, if you say, hey, I have all of this brownfield, this is too much to get started, or like, where do you start? Well, just pick one application, right? It can be simple, can be a little more difficult, can be on whatever computer. Just pick one thing that works well for you, or use a situation where somebody is creating a new workload, a new service or whatever to actually build that platform. If you don't get started now applying these modern principles and really building these digital factories, so to speak, then you will create more and more and more and more legacy in brownfield, and it won't get easier. So just jump, have a look, start with this. And if I can help you, if we can help you, we do this all the time, then please reach out. I hope you enjoyed this video. If you have any idea what you want to cover, you want to show me your setup, again, invited to do that. Thank you so much for listening. Leave a like and maybe share this with your friends and colleagues. Thank you so much.